Welcome to this case study video section on engineering thermodynamics about gas cycle. So, first of all, what are the gas cycles will be followed in engineering thermodynamics? The first cycle is an Otto cycle. So, the Otto cycle is another name is constant volume cycle because of in the PV diagram here is a two constant volume cycle and two adiabatic cycle. So it's also called as constant volume cycle. So in this Otto cycle, the term will be introduced in compression ratio. So it is defined as it is the compression of before volume compression to compression of after the volume compression. So the next air standard cycle is diesel cycle. So here the diesel cycle will be followed as one constant volume cycle, two adiabatic cycle and one constant pressure cycle. So in this term we need to find the efficiency of one diesel cycle with respect to the work done to heat supply. Here it is a work done, it is a combination of the all four process is constant pressure and two adiabatic and one constant volume. And finally, we need to find what is the mean effective pressure of these two cycles. So the mean effective pressure of these two cycles, it is in a ratio of work done to the swept volume. Okay, fine. Now we will go to the another cycle is a dual cycle. It is called as a constant pressure cycle. It is two constant pressure and one constant volume and two adiabatic process will be in there. So these are the cycles will be followed in the applications of an engines. So now we will go to the how to the working section of engines in thermal applications using these gas cycle processes. So in these gas cycle processes, the first of all the atmospheric air will be goes to the diffuser section. So the diffuser section is after that it is will be goes to the compressor. It will be compress low pressure air into a high pressure. And then it's next allowed to the combustion chamber process. So here the combustion chamber, the temperature and the pressure value of the atmospheric pressure will be in a increasing level, and the next it will be goes to the turbine section. So here it is in a turbine section. It is used for producing mechanical energy using this atmospheric pressure and temperature with respect to the these gas cycle processes. And finally it will be goes to the nozzle section. So here it is the nozzle section. It is used for increase in velocity. So this velocity will improve the engine efficiency. So this is the reason for the aircraft will be goes to the forward section. It is called as thrust. For the negative section of this thrust, the drag will be produced in the back movement force of the aircraft. So the thrust is equal to the drag section and weight is equal to the lift section of the aircraft. So this gas cycle is applications to the engines work done, and also the ships will be working is condition of the gas cycle processes using is an dual cycle. It is a best example for the applications of these engines in working in marine applications. So in an Otto cycle, it will be the applications of an automobile engines, and diesel cycle will be also applicable for the automobile engines and aircraft engines during this process involved indication section. So the final one is a mean effective pressure. It will be the ratio of, already we said it is an work done to the stroke volume. The stroke volume means it is the differentiation between the initial volume of the compression section to the after volume of the compression section. Thank you.